I've published two sets of slides, one on JavaScript objects and the other on JavaScript functions. I do think at this stage, maybe I could almost skip over the JavaScript objects set of slides. That you should flick through them yourselves. There are 1 or 2 points that I will bring up, all right, maybe this morning. And then I will cover the JavaScript functions one, all right, though, because there's some stuff in there that might be useful to you in this module, and perhaps even more so in the web dev module. So if I just bring up the first set of slides, and I'll just talk about points that might be relevant from that set. I'm going to skip over all this stuff here. Do be aware of something called ECMAScript. ECMAScript here. ECMAScript is a specification of a language, and the only implementation of that specification is JavaScript. And JavaScript actually predates ECMAScript. The first ECMAScript specification you can see down here was in 1997, whereas the JavaScript language dates back to 1990/91. So there's a history as to where ECMAScript came from, which I'm not going to go into. But just be aware of the fact that ECMAScript is the specification for the JavaScript language. And there have been a number of evolutions of that specification. The landmark one was in 2015, which we call ES6, ECMAScript 6. So you'll often hear me, and perhaps Roseanne as well, in web dev talking about pre and post ES6 JavaScript. We often refer to ES6 JavaScript as kind of modern JavaScript. And there's an ES7 and 8 and 9, as you probably know. There's a release of this ECMAScript, an update to the ECMAScript specification, essentially every year since 2015. 2015, the ES6 or ES 2015 specification introduced classes to the JavaScript language, which weren't part of its native. And in fact, classes in JavaScript are not native at all. Unlike Java, for example, where classes are native to the language, they're not in the case of JavaScript. They're actually converted back to functions behind the scenes. The problem, though, is, okay, we might write modern JavaScript, but there are lots of web browsers out there which predate 2015, and they cannot run that JavaScript. So we need to convert any modern JavaScript that we write back to ES5. ES5, we know every browser, new or old, can run ES5 JavaScript. We don't have to worry about that conversion, though. There is a tool that does that for us called Babel. The process of converting modern JavaScript back to pre-ES6 JavaScript is called Transpilation, and it's done by, there's actually more than one tool now, but for a number of years there was only one tool, and it was this Babel tool. You will be using Babel an awful lot in the web dev, not directly, though indirectly it's being used there. So you just need to be aware of this relationship between ECMAScript and JavaScript, and the notion of modern JavaScript, which is ES6 plus, and probably old kind of vanilla JavaScript, which is ES5 JavaScript. Node was a real game changer when it came to the Node.js platform, was a real game changer when it came to JavaScript, because pre-Node, which is pre-2009, the only place you could run JavaScript was in the browser. And so JavaScript data representation is all about objects. There are some primitive types as well, but it's all about objects. And that's where I think you're comfortable with object manipulation and object navigation, or at least it's important that you would be comfortable navigating objects, an object network JavaScript is a dynamically typed language, which means you can change the type of value that you assign to a variable at any stage. That may not be a great thing to do, though, but you can do it. So I'm just going to push on. So in the lab, kind of accompanying these slides, which he actually walked through the last day, you might remember what I provided was an archive that you could unzip and import into a good download and unzip and import into VS Code. And in order to run the code in the archive, then what I asked you to do was to install an extension to VS Code called Live Server. All Live Server is a simple web server. And when you install it, then you get this Go Live link in the status bar of your VS Code, which is down here on the bottom right. And if you click that, you're essentially just starting a HTTP server, and it will serve the contents of whatever you're looking at. So in our case, the only thing it can serve is this index.html. So if I start up my live server, there we go. And that's all the index.html generates. We're not interested in the HTML. What we're interested in, though, is what's happening in the console of the browser, in the developer tools. So what you need to do is open up your developer tools. And developer tools is something that you will need to have open more so for the web dev module than this module, because if things go wrong, the only place you can do any kind of debugging is in the actual browser itself. And so the way you were kind of meant to kind of play with this code is go into the index.html and enable these script lines kind of one by one to get an understanding as to what the script is doing and to build up your knowledge of JavaScript objects. But of course, as I said, it seems to me that you're comfortable with JavaScript objects anyway. But I am going to jump into this one here. So I'm just going to enable that script. And I'm going to disable everyone else. I'm going to disable this one because I don't really need it. And the nice thing about the live server is when you save any changes that you make, then updates are pushed out to the browser tab. So that's kind of convenient. We don't have to do manual refreshes. So I'll save that. And the script that's enabled now is this 01 nested. Did I enable the right one? Yeah, 01 nested objects, which is this one here. Sorry, 041. And so I've just got a simple nested object data structure here. And all I want to highlight is make sure that you're comfortable with this kind of stuff, that you're comfortable using the dot notation and the subscript notation when you're trying to navigate a network of objects. Okay, I'm kind of referring to this up here now as a network of objects. I've got an outer object, which is a me object, and then I've got nested objects inside it. So you need to be comfortable navigating this entire structure. And so, for example, an expression like this here, using the dot notation first and then the subscript notation, I'm assuming everybody is comfortable with that expression there that I've highlighted. Similarly, that you're comfortable with this expression over here, and that you can mix and match the dot notation and the subscript notation. This is the dot notation, whereas this is the subscript notation, and you can mix and match them as much as you want to. It's almost a matter of, in many cases, it's a question of which you prefer using, which style. There are rare occasions when you have to use the subscript notation. You cannot use the dot notation. So I'm going to assume everybody is comfortable with that. But I'll pause for a second just in case anybody wants to ask me something, let's say about this expression here. No. Okay, I'm going to push on, and I'm going to push on to this script here, which I'm going to enable first. So we're on to 043 pitfalls. Save. Now, before I go to the browser, so here again, I've got my some objects. I've got the me object, and here what I'm doing is I've got a property called name, and it's referring to a variable which happens to have the same name, called name, and that variable is this object up here. That's fine. That's not unusual. I'm going to skip over this line for a second. I'll come back to it. So, but essentially, I've got nested objects here. I've got a nested object inside the me object, and I've got another nested object here. So I've got some console.logs here, and I've got a console.log of me.finance.deposit. So me.finance brings me to this object here, but that object does not have a property called deposit. So my question to E is, what is that console.log going to output to the screen?
Null.
Pardon?
Null.
Good guess, but wrong. So there is a reason why I'm drilling into this. Undefined, correct. Whenever you have an expression that's trying to refer to a non-existent property of an object, deposit does not exist as a property of finance. What the JavaScript runtime will evaluate that to is the value undefined. Undefined is an actual primitive value built into the JavaScript language, and it's different from null. It's a peculiar thing. People aren't really clear why Bernard Ike, the guy that designed JavaScript, distinguished between null and something else that kind of means null. But so the correct answer is the value undefined. It is an actual primitive value. If I just go back to my slides and I go back to this one here, where I'm talking about the primitive types that are just built into the JavaScript language. Well, apart from numbers and strings and Booleans, there are these two other types, stroke values, one called null and the other called undefined. You would think they serve the same purpose, but they don't, and I can't go into any detail as to the only time a variable will have the value null is if you explicitly assign it that value. If you declare a variable and you don't initialize it, then by default it has the value undefined. That's one case where undefined arises. The second case where undefined arises is what we're just talking about right now. When you try and reference a property of an object, but that property doesn't exist, then the runtime will evaluate that expression to undefined. Okay. So it's not an error though. Like if I have a console.log down here, if I just do a console log of that, this console.log will still execute, which means this line here, yeah, the line that I've highlighted now, it doesn't throw an exception and cause your program to crash. And I can prove that to you. I'm going to take out this line because that's going to be problematic. So I've saved my file. I go back to my browser. And, you know, hello is actually appearing as well as undefined. The next question is, what about this line here? Supposing I think that deposit is a valid property, and I think that it's an object, and I think it has a property called the bank. Now, what is that console.log going to output? We already know now deposit is not a valid property of finance. And in fact, this expression here is going to evaluate to this odd value called undefined, which, number one, undefined is not an object, it's a primitive type. And either way, you cannot try and reference something within the undefined thing called bank. So the question, my question now to you is, what is going to happen when this line of code executes? Anybody want to guess?
You're going to get an error.
Okay, and my next question is that line going to run?
No.
No. So this line is actually going to, this line here is going to cause the program to crash or throw an exception. And let's prove that to ourselves if we save it. And there's the error. And this is an error that pretty well everybody in the class is going to get at some stage, more so in the web dev module than in this module. So I'm highlighting it now, but probably when it arises, you're going to scratch your head and think, what's this error all about? The nub of it is you are trying to access a property of an object where that object actually doesn't exist at all. And that's kind of what is arising here. You know, the deposit object doesn't exist at all, but you're still trying to reference a property of it. Right. And that's something that I highlight here, just to flag it down the line. That's all I want to do in this set of slides. So I'm going to move on to the second set of slides. So the second aspect of JavaScript that I want to talk about is functions. So the slides that I'm looking at right now, you can find here, if you need to look at them yourselves later on. So functions are how we kind of represent or how we kind of encapsulate behavior as opposed to state. Objects are all about representing state, whereas functions are all about representing behavior. And they are the fundamental unit of composition for logic in JavaScript. And they're natively built into the language. I said there at the outset, JavaScript, modern JavaScript also has classes. And classes, if you think about it in the context of Java, a class is a way of composing logic or behavior. JavaScript does now have classes, but they're not actually native to the language at all. When you transpile using that Babel tool, modern JavaScript back to plain pre-ES6 JavaScript, then all of your classes actually get converted back into functions. You don't need to worry about what they look like, but they do anyway. So functions is the only construct that's available to us. And there are different ways of encoding functions. You can use, from day one, you can use what are called function declarations. Alternatively, you can use functional expressions. I'll show you examples of these in a second. There was this odd thing called hoisting in JavaScript from the outset, which we can skip over now because it's not really relevant anymore. When ES6 came along, they introduced what are called arrow functions, which is really a cleaner syntax for, and it's kind of an alternative to these two up here. But you'll still see these two being used a lot, and you'll see me and you'll see Roseanne using them a lot, as well as arrow functions, which we also use a lot in our code. There's a shortened version of arrow functions as well. And arrow functions and the shortened version of arrow functions were all about trying to reduce the amount of physical syntax that we had to type. They served other purposes as well, but that was one of their objectives. And also from the beginning of JavaScript, there was this notion of anonymous functions, a function that doesn't have a name, which seems an odd thing. If a function doesn't have a name, how can you invoke it? Where in fact, it turns out that anonymous functions are used an awful lot in JavaScript, and we'll see where they arise. Now, similar to the data's structures, and I'm also providing an archive that you can download and unzip and import into VS Code. That archive is going to be available to you in the next lab that we'll have next week. Next week's lab, if I get to finish these slides, which it's unlikely that I will today now really, but the second lab, next week's lab, is all about JavaScript functions. But there is an archive that comes with it, and when you download and unzip it, then and import it into VS Code, what you get is this. You won't have a backup folder, but you'll have everything else. So it has the same kind of layout as before, really. I've got one index.html, which looks similar to before. It has a whole load of script tags, and the idea is that you enable them as you kind of walk your way through the scripts to develop your understanding of various aspects of JavaScript functions. And I've got some JavaScript files. So if we look at this one here, which is this file. So there's a lot going on in this, and I'll just scan down through it really, because it has some of the basics of JavaScript functions, all of which I'm kind of assuming that people know already. It's the same old story. We start up our live server. We already have a live server actually running in the other tab. You can stop it if you want to. You don't have to, though. You can have multiple live servers running. And in fact, let's do that. And they'll be running on different ports. So I'm going to start up this live server here. And here we go. Again, we're not interested in the HTML. We're interested in what's going on in the developer tools console. So all of this stuff here now on the right is all being generated by that JavaScript file that I have referenced in the script tag, which is the stuff here. So take it from the top. Okay, I've just got a simple object because I'm going to be using that later on. I've got a me object. I've got a her object. So the idea, just to explain, is I have two objects here that kind of represent people, and I've got an object that represents a place. Okay, so the first thing I'm demonstrating here is what are called function declarations. If I just flip back to my slides, I said you have function declarations and function expressions. Well, if you declare a function like this, it's called a function declaration, where the name of the function is what we have here. These are the parameters to the function, and the body of the function is always wrapped in curly braces. I'm assuming you all know that. Just to see what the function actually does based on its name, it's hopefully explicit. The idea is that this function, you pass it an object, and it tries to determine whether that object is representing a person or not. Because JavaScript is not statically typed, we have no control over what type of object somebody might pass into this function when they invoke it. And I've just arbitrarily decided the way I determine whether this object represents a person or not is to check to see, does the object have a name property, and does it have a gender property? I'm assuming people, I shouldn't be saying that really. What I'm doing here is this is the in operator allows me to check whether the thing on the right, which happens to be which must be an object, contains the key on the left, and you have to wrap the key in quotes. You have to make it a string. Similarly here. And just let's assume that, for the sake of argument, any object that has a name and a gender, then that is probably representing a person. Okay, so that's what that function does. But the main point that I want to get across here is to say that this the way we've declared this function is using the function declaration syntax. And you can see me just invoking it here. So these two consoles generate a true and a false, and that would make sense because in the first invocation I passed it. In the first invocation, I passed it me, the me object, which is a person object, and in the second invocation, I passed it the here object, and the here object is representing a place. So, and it doesn't have, it has a name property, but it does not have a gender property. The next example is an example of function expression. This is an example of where I'm declaring a function, but I'm using the function expression syntax. And the way that works is you just declare an ordinary variable. You can use const or let, but it's probably best to use const. And you assign that variable a function. Note, I'm not giving the function a name here, whereas in the earlier example, I did actually have the name of the function. But when you're using function expressions, the function that you're declaring gets its name from the variable. So I'm essentially declaring a function called add middle name. And the idea of this function in my head anyway was it would be passed an object representing a person, and it would be passed a string. And the purpose of the function is to add a new property to the person object called middle name, or add a new property into the name part, where the property would be called middle. So you can see here the me object doesn't have a middle name property, whereas the her object actually already has a middle name. So if I try and add a middle name to the her object, what I want my function to do is to give that person two middle names. So it would be Yvonne something else would be their middle name. And I'm just doing some sensible checking first to make sure that the object that's passed in is a person, otherwise throw an exception. That's normal kind of stuff. And all I'm doing here is checking to see, does the person already have a middle name? If they do, then extend their middle name. If they don't, then add a new middle property to the name part of the person. But our focus is more on functions here now, rather than me having to explain this kind of having to explain the body of the function line by line. I'm assuming people are comfortable with that code that I've just highlighted there. They can follow the flow of control. And here then is where I'm actually checking that my function works okay. I have to wrap it in a try catch block. Why do I have to wrap any invocations of add middle name in a try catch block? I didn't do it up here when I was invoking the validate person. I didn't wrap that in a try catch block. Why am I wrapping this code here in a try catch block? Anybody got a sensible explanation of that for me, I wonder?
In case the middle name you're trying to add isn't valid and you get an error.
Right. It's because add middle name has potentially, it could throw an exception. And whenever a function may throw an exception within its logic, then you have to wrap the invocations in try catch. Yeah, great. Moving on, arrow functions, which was introduced in ES6 or probably ES7. So the syntax here is you don't actually have to use the keyword function at all. So here's where I'm declaring a function using the arrow syntax, the arrow being kind of this part here. So the bit before the arrow is the parameters, the bit after the arrow is the body of the function. And it's a bit like function expressions in that we assign it to a variable. So solution now becomes the name of a new function that I've just declared using the arrow syntax. And what does the function do? Again, it seems to check to see if the object that's passed in is a person or not. And if it is, it will determine what their gender is and return. What does it do? It returns a string which either has Mr. or Miss in front of it, depending on the gender of the person. Okay, not too exciting, but the important part that I want to get across is make sure you're comfortable writing, declaring functions using the arrow syntax. And so you've got an example of it here. Now, the arrow functions, they have a shorthand version as well. If I go back to my slides. So arrow functions, you can read all of this stuff yourself. So here I'm talking about certain parts of the arrow function declaration, certain parts of the syntax you can leave out in certain situations. And so just to explain it, if, because I think I have a shorthand version of an arrow function here. So there's a couple of parts to it. In fact, I could make it even better again. I can get rid of that and that. And so the rules are, if your arrow function only takes one parameter, then you don't have to have the parentheses around it. They're the parentheses. You don't need to use them. So it's just slightly less typing. The second rule is, if the body of the arrow function consists of just one line of code, then you don't need to use the curly braces. So up here in my arrow function, I wrapped the body in curly braces, in the curly brace. Whereas down here, I'm not using the curly brace at all. That because there is only a single statement. That single statement is the body of my arrow function. So that's rule number 2. You can omit the curly braces if the body only consists of a single statement. And the third thing is, you do not have to use the returns keyword either. Obviously, the return value of this arrow function is whatever that expression evaluates to. Up here, I did have to use the return keyword because my function was a multi-line function. So I had to tell the runtime which statement actually generates the return value of this function. And you will see this shorthand version being used again, perhaps in this module, but also definitely in the web dev module. So make sure you're comfortable with all this syntax really of functions, and in particular arrow functions, because they are becoming the dominant form that we're using now when we're writing JavaScript code. There's less of the function expressions and function declarations. If I wanted to be explicit then and not use this shorthand version, then what I should do is put my parentheses here. And it's probably a good idea, if you're not familiar with these arrow functions, to be explicit. The next thing I should do is have my parentheses. Now, when you put parentheses into the, wrapping the body, you must use the return keyword. Otherwise, in fact, I think it's probably going to throw, if I just save that. If you actually look at what's being generated in the console logs for this particular part of the script, it's going to be incorrect. In fact, it's from here, right? See, I'm getting undefined being returned, and that's not really what I expected. I think I expected a Boolean true or false, and that is because this function here that I've just declared now, it's not actually returning anything because I don't have an explicit return statement in it. So I need to put that in there. And if I now save it, you can see here, right, the shorthand part of my script is returning Booleans, which is what I wanted it to console log out. That's what I'm doing. As you can see, what I'm doing is, what does the function actually do? It checks to see whether it checks to see whether the person object that's passed into it, whether that person currently has a middle name or not. And again, I have to first of all check to make sure it is a person object. And then once I establish that, I then check to see, does that object have something, does the name object within the person object have a property called middle? And then finally, we have anonymous functions. I am going through this at a fair pace now, admittedly, again, because I think people are fairly familiar with JavaScript. So you may need to go back over these, and you should probably go back over the code that I've just stepped my way through there and make sure you're clear on all of the syntax in it. I'm going to skip that for now. All I'm saying here, right, is that arrow functions came in ES6 or post ES6, and that has to be transpiled back to pre-ES6. What I'm showing you here is a screenshot from an online tool, and it's actually the Babel tool itself. There's an online version of it. If you go to babeljs.io, and if you click on the try it out link, what you'll see is this here, right? And what you can do is you can paste in modern JavaScript into the box on the left, and it will show you the equivalent pre-ES6 JavaScript code on the right. Okay, because many browsers, certainly the old browsers, won't be able to interpret arrow functions. This is what they look like in old JavaScript, and you can see it's actually converting it into function expressions. Var is an old way of declaring a variable. We now declare variables with the let and const keywords. I'm going to skip over constructors because that doesn't really bother us anymore. In fact, I might skip over all of this. Higher order functions are functions that take a function as an argument, and presumably the function that is receiving a function as an argument, the outer function will invoke that function parameter somewhere within its body. That's the intention or the expectation. But just in terms of what is a higher order function, it's a function where one of its parameters is also a function. The function parameter we refer to as a callback. That's the term that we use, which I'm mentioning here. And usually these callbacks are coded as arrow functions. Well, sorry, they're coded as anonymous functions. An anonymous function is a function with no name. We don't have to give a name to the function that we pass in as a callback. The parameter, whatever name we give to the parameter, will be the name of the function. That's kind of how it works its way to being able to reference the callback function. So we tend to use the anonymous function syntax, which we haven't seen so far, but I can show you now. And these anonymous functions, that tends to be the only place we use them really as callbacks. So by way of illustration, I'm declaring a simple array here. And I'm kind of assuming people are familiar with the for each method associated with the array type. What the for each method does is, well, first of all, it is a method associated with the array type, and it expects one argument or parameter, and that parameter has to be a function. Now, you can code that function any way you want to. I'm coding it here using the arrow syntax. And also, it's an anonymous function because the function which begins here and ends here, strictly speaking, that function has no explicit name. So hence we would refer to it as an anonymous function. And I'm kind of assuming that you already know what is this function, how is it used? And the way it's used is the for each method is going to invoke our anonymous arrow function once for each element in the array. And for each invocation, it's going to pass 3 parameters to that anonymous function. It's going to pass a reference to the current element in the array that's being processed. It's going to pass the position of that element within the array. And it's also going to pass it a reference to the entire array. So this anonymous function here is going to be invoked. The first time it's going to be invoked, it's going to be passed in the value 2 for n. Index will be 0. And the array parameter is going to refer to the entire array. The body of my anonymous function is not doing anything interesting. It's just doing a console.log. So there's 2 points that I'm trying to get across here. One is this notion of anonymous functions, which we have here, which we haven't have encoded using the arrow syntax, but we could have used the function declaration syntax as well. Or alternatively, we could have declared the function up here, assigned it to a variable, and then just use that variable down here. But it's more common to use the anonymous function approach. And the second thing is to say that for each is an example of a higher order function stroke method. We can use the word method and function kind of interchangeably, because really all a method is a function associated with a particular type. In this case, it's associated with the array type because this thing is an array. So for each is a simple example of a higher order function because it takes a callback as an argument. Some higher order functions can take many arguments. It just seems, or it just in this particular case, it's just that our higher order function for each only takes one argument, which is the callback. Now, I'm not going to rush it now because it's kind of important, but to give other examples of higher order function, we're actually going to stick with the array type. The array type has a number of other methods which also exhibit this higher order function characteristic. So there's the filter method, the map method, and the reduce method. Could I just maybe ask, so have you seen, or are you familiar with the filter method associated with arrays? Anybody? Might be just a no. No, we're not familiar with filter.
It returns all the ones that match the criteria.
Yeah. Would you have covered that formally in some class?
Yeah, well, yeah, I think so. We did it in Android in Kotlin anyway.
Oh,
basically the same thing.
in Kotlin?
Yeah.
Yeah, okay. And so map, would you have come across the notion of a map method associated with an array as well? Can't remember, maybe it's okay.
Is that like creating a hash map where you're creating like key value pairs?
No,
No.
no. That's the map data structure type.
Yeah.
The map function is slightly different. All right.